Everybody, today we'll do another problem, and today we will have to do probably right. So, um, we will do a problem that is related with the application of calculus of trigonometry. We will do this problem. Um, so the problem states like this is a word problem, pretty much. I think that one that works. Okay, it says, okay, okay, it says to find the width of a meter a surveyor a surveyor set up a transit set up set up a transit right, point C at point point C. I don't know if this is clear enough, but at point C, and on one river bank, on this is even worse, to find one that is working better. Nope. Riverbank. Site. 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 Directly. Direct. Directly, right? So it's site directly to, okay, across point, and site directly across point B. Across point B, right? And on the other riverbank. On the other river bank, right? So then then the surveyor then walk on the bank. The surveyor then walk along the walk along the- for for a distance for a distance, right? For a distance of 200. Okay, for a distance of 275 meters to point A, to point A. Okay, the angle is the angle the angle is C A V. Angle the angle say the angle CAV is 57 degrees and 28 feet. Right? So I guess we put this right here just to have the information, but we don't need that. We don't need that 28 feet of okay. So because we have the distance in meters and whatever, this is just a number given based on that angle, so it doesn't matter. We don't need it. Now the question is, so so we have a river, and right now, let's say this is the channel of the river. This is the deeper part, right? You fish for catfish. This is what you actually cast and use chicken livers at. And and so we have a point B around here, and then we have point C around here, and we drop a line straight. This is B, this is C, and then we have an A, we have a point 8 here, This is A, and this distance is given to us, right? So this distance was given to us. This distance from point A to point A to point C. This distance when the guy walk across the bank from C to A, that is 175 meters. Now we drop, right? We drop. This is point A. This is point B. So the distance from here to here is 200 and 275 meters. And so we know this distance, right? We don't know this distance. We don't know this distance, but this is the one that we try to find, right? So the question at the end of this, right? At the end of the day is what is, okay, estimate width of the river. Question is what is the approximate approximate width of the, right? That's the question. So this is what we're trying to find. What is the approximate width, right? It says right here to find the width, right? Of the river. So what is the width, right? So we care about some numbers, right? If a number was given to us, it's given. One is given, so we need to find the rest, right? Okay, so the question is, right? So based on this information, right? What can we do, right? And we have something back here that also we can use that is called this guy, the 57 degrees, right? Which is, I'm trying to do it another color, but apparently not going to work. So this angle right here is 57 degrees. Okay, so this angle right here is 57 degrees, right? So now, as we can see, as we can see that we don't have a lot of information, right? So we don't have a lot. But what we have is that we can try to see, right, what can we use over here in order to find that, right? Now, I can do two things, right? So what I can do, because I don't have anything on this side, but I have something on this side. I have something on this side, right? If I have something on this side, what is it? So I have something here. Now, um, and I use, one of the tools that we learned in trig, right? Of course, we can use a few. So we can use a couple different tools, and that's why I always recommend to somebody who want to do this is that always try to use the simplest tool that you have in a toolbox. Okay, so you might know some sophisticated tools, but if I can't solve my problem with the basic tool, I just go with the basic tool. Right? So now I know that if I say data is, if I say data is equal to 90 degrees, right? Inside a triangle, inside a triangle, right? Then I can say that data, right, equal 90 degrees. So angle is 90 degrees, right? But then I can call another data, and then I can say data 2. We can say data, data 2, data 2 is equal to data minus data 1. So I am looking for another angle. This angle is inside a triangle, which is 90 degrees. But I'm looking for another angle because I don't have the information for this. I don't have the information for this. So I can use my trigonometric tools, right? So now say that data 1 is the one given, which is this was not given. This should be in my brain, right? It's not that you know about that. In a right triangle, there's 90 degrees, right? Assuming there's right triangle. And and then what I can do is assume that in this data one, right? Data one is equal to 57 degrees, right? Okay, so data two now is going to be the third angle, right? And this is because I have one angle minus data one, so data two is equal to 90 minus data one, which is 57 degrees, right? Which is equal to 33 degrees. Now, data two is 33 degrees, right? So now what can I do? You know the sine of data is equal to opposite, opposite, right? Opposite over the hypotenuse, right? Over the hypotenuse. Now we can say that this angle right here, this data, right? So data, we can say that data sine of data two, right? Because that's the angle that I have, which is this one, is equal to opposite over the hypotenuse, right? And the hypotenuse, I don't know, but I know the opposite, right? So sine of 33 degrees is equal to opposite, which is the opposite in this case, the data. So my new triangle, let me write it right here. So new triangle look like this. Okay, so this is 275, 275, 275 meters, right? And this is my data two. And this is data one right here. Data one was because I used it just 57. And this guy right here is what? Is 33 degrees, right? Hmm. See, two is the opposite of this guy. So I can use sine, right? Sine, right? I don't know the hypotenuse. That's what I'm trying to find. So right here, I can say 75, 275 over the hypotenuse, right? I don't know the hypotenuse. Great. So based on that, based on that, sorry, I have to get a calculator. So based on that, right? So what we can do is the following. So we take the sine of 23 degrees. Okay. So now sine of 23 degrees, right? Let me show that is in degrees. So sine of 33 degrees. Now, so now this guy right here evaluating this. This is 0.54445. Here 5 equal to 275 over hypotenuse. Okay, cross multiply, and I get that point 545 times the hypotenuse equal to 275 divided by five point 545, 0.545, right? And divided by 0.545, then 275 equal to hypotenuse is equal to 503 meters. Okay? Not the hypotenuse. Okay? The question is the hypotenuse what I'm looking for? No, no. Okay? I am looking for this, right? But the only reason why I am going this process is because I didn't have anything to help me in this side. So next of having this, again, going back to the tools that we know, right? I don't I know this now, which is this guy right here. Okay? And I have fun, wolf, four. I think it's 504, I believe. Yep. Actually 505. Yep. It's 505. So this is a 505, right? Mhm. You can see that this guy right here, I have this. I'm looking for this guy. Now the question is, again, if I am fixing a car, if I can fix the problem that I have in the car with this good drive, why I need a wrench? Right? I mean, I guess I can, right? If I have an app and I can get, maybe some type of screwdriver into an adapter. But why I could complicate myself going through the process? What I have spice. Okay. I got a one, two, we're missing the three. And instead of going with the trick functions, if I why not use Pythagoras? Okay. So now, this is what I'm looking for. Right? Well, let's call this guy, let's call R with river. Okay. So let's call this guy whatever. So river width, right? And you can say that the river width is square, right? If you want to be more, this is bothering you, right? Because normally we start with the A, assuming that the A, right? So we can say that A is square, right? Assuming that's A plus river width plus river width square is equal to hypotenuse. Hypotenuse square. Okay? So I got my hypotenuse here. Okay? So I got this guy, right? So now 275 squared plus river width square is equal to my hypotenuse is this guy. So it's 505 squared. Once I do that, so that is equal to, and this side is equal to 2546. 46. And right here, 275 squared is equal to 756 25 plus r with the square is for that. And the square is one of the one that we trying to find, right? That's so now I subtract this guy 75625 75625, right? Mathematics, we follow a process, right? Um, so it's not that you actually memorize things. You follow the process, you understand it. You actually do not memorize anything here. I mean, you can memorize the tools, stuff like that, like in 90, whatever. And but then this problem, we use our brain to kind of come up with a solution, right? And, to be different all the time, right? Basically, what's called problem solving. If the problem were already solved and anybody can memorize it, then there was no point to becoming engineers, right? We need to solve problems that are different every. Okay, so now what we do right here is okay. So we subtract, we subtract 254946 minus second answer, and I got all with equal equal 79 3 to 1, and of course this is squared, right? And because this is squared, we need to take the square root. We need to say r with, take the square roots on both sides, and then 17932 3 to 1, right? And then take the square root of that. So when we do that, and then I got r width is equal to approximately 424 meters. So we went through the process, right? So I understand the problem. The surveyor then walked a loop bank for the distance of 275 meters. He walked along this distance to point A. The point was given when he placed it at the tripod already, pointed the direction to point B. Instead of the angle, you saw that the angle was at 57 degrees, right? And then at that moment, with that information, we set out the problem and using the basic trick, right? So subtract from data 2 is equal to data 90 degrees minus data 1, and we get 33 degrees, right? We use the 33 degrees as a data 2, and then plug it right here. We found out that the value of that data 2, the cosine, was 0.545, and we solved for the value. Once we get the hypotenuse, we have perfect, right angle, right. Basically, what we did now is basically use the Pythagorean theorem to kind of calculate this, um, calculate the width of the river, right? So basically, that's how. I mean, you're going to how to use you can actually look it after this. You can actually use the law of sines also to do it, right? Because you already have or you can use length. Why? Because tangent is sine over cosine, right? But then you don't have right here, but you have the angle, so you can actually use the opposite of that, the opposite of the hypotenuse, because we already have the hypotenuse to find. Um, yes, we can use the tangent to calculate this because basically we have this is right here is the opposite from this, right? But then also you can use different ways to solve this. Matter of fact, like you can actually use cosine of that, and I'm pretty sure you get the right answer too. But yeah, so basically you take cosine of different techniques to solve a problem. So basically, um, because you can actually use tangent to do it if you wanted to go through that pain. So basically, what you can also do is the following. So using tangent, but again, the Pythagorean theorem works good. So tangent of data. Okay, so tangent of data is equal to what do we have here, right? We have CA, right? And VC, right? CA, VC. We're trying to find VC, right? So, but we have AC. We can use AC or here too. VC. So we can do. So is that VC over CA or AC? Doesn't matter. AC. You read this. This is B. This is this is A. This is A. And this is actually no. This is C. C. And this is B. Right. So Now, if you look at this, what do we have? We have this distance, right? So if we have that distance, what we can also do, we can say that VC, okay, so VC, right? So VC, VC, right? So now we have this, right? So now we can say that this times this, right? Solve for that, right? We have BC is equal to AC tangent of data, right? Okay, so then we can say, okay, so what is it, right? So VC is equal to what is AC? We say this distance, right? The distance from A to C or from okay, so now we put 275 meters, tangent of the angle of that, right? Which is in this case is what is 57 degrees. And then BC is equal to what? BC C is equal to 424 meters. Here you go. See, there's a lot of ways how to get it done. Many, many, many ways. So that's it, guys. That's it for today. And I hope you have a beautiful day. Hope you learned something. And I see you in the next video. Thank you for watching.